Hello everyone, welcome to another video, and in this video we're going to talk about a question called intersection of two linked lists. So the question suggests that given heads of two singly linked lists, head A and head B, return the node at which the two lists interacts or intersects. If the two linked lists have no intersection at all, return null. So what it says is that we have two linked lists, and at one point the next pointer of both the lists will point to a different linked list or a common linked list, and we can call it intersections. Let's discuss that on the whiteboard. So let's take an example where we have L1, and L1 will contain our let the nodes will be 4, pointing to 1, pointing to 8, pointing to 4, and pointing to 5, and this will be null, right? And another list will start from 5, going to 6, going to 1, going to 8, going to 4, going to 5, and going to null. Since the question says the two linked lists are have intersections, so basically those are not two independent linked lists. Here we can take it out, and this one pointer can go to 8. This is how it happens, right? At the next pointer of the L1 and the next pointer of L2, right, at 1, this next pointer and this next pointer will be pointing to a common list. So we have to find the intersection, and we need to return the node where it intersects. So this can be done in two different ways, right? So in one way, what you're going to do is, like, while we are going we're going to traverse first in L1, right? Like 4, 1, then 8, then 4, then 5, and null. And as we go from left to right, or as we traverse through the list, we're going to keep saving those in a set, right? 4 node, then we're going to save 1 node, then we're going to save 8 node, 4, and 5, so on. Second time we're going to traverse from 5 or head of the L2, and when we traverse from head to tail, we're going to see if the node is present in the previous set, and the time we find the node we can return it, and that will be the intersection. Okay, this is one way to do it. Another way is like let me show that as well. Another way is like our pointer way. So we can use pointers. So what happens is, see, if our pointer starts from L1 pointer starts from 4 and our L2 pointer starts from 6, right? Then the length of L1 and L2 will be same. If length of L1 and L2 become same, then when we increase the L1 by one pointer, like L1 dot next, same as we're gonna, if we increase L2 dot next, at one point L1 and L2 will intersect, so both will become same, and we can return that. But here what happened is, both the lists are not of same length. So how are we going to solve it? See, our goal is to get the pointer L1 at 4 and one pointer at 4 and one pointer at 6, right? After that we know that we're going to get the solution at 8, because both pointer will become same. So to get that, let's start L1 at 4 and L2 at 5. Now let's keep increasing it. L1, then L1 go to 1, L2 go to 6, then L1 go to 8, L2 go to 1, L1 go to L1 go to 4, then L2 go to L1 goes 1, 2, 6, 4, 5, and L1 L2 goes to 8. Now L1 goes to 5, L2 goes to 4. Now when L1 become null, if null, then we're gonna put this pointer to L2. So now this one become L1 and L2 becomes 5, right? Now L1 becomes 6. Now L2 goes to null. When L2 goes to null, we're gonna give it to L1. So L1, then L2 will go here to the head of the L1. At this point, you see that our both pointers are at 4 and 6. Now you just keep increasing the pointer, we're gonna get 8. So basically what happened is, to achieve the goal, to start the pointer at the same length, what is gonna happen, the pointer that reaches to the null first, we're gonna transfer the pointer to the next head. And in that way, what happened, this will become L1 plus L2, this is become L2 plus L1. Length, so length becomes same. So, and whatever the extra item, that will get covered by the time we reach null. And by the time each pointer get to the null and get transferred to the head of each other, the time we are traversing, at that time, the pointer will be at a position where from where the length will be same. When the length will be same, then we know that when we increase this by 1 and this by 1, it will be intersect at 8 and give us the answer. Okay, if there is no answer at all, then definitely both will intersect at null. So it will return null anyway. And that's what our question asks, that if there is no intersection, it will return null. So at the end, if nothing matches, it will return null anyway. It will match, both will match at null. So let's try to implement both the solution using JavaScript. So in first solution, what you're gonna do is we're gonna create a set, right? And then we're gonna traverse through one head. So while head 1 equals to head 1 dot next, and then set dot add head 1. That's it. We created the set here with every single nodes of head 1. Now we're going to traverse through head 2 and we're going to check and we're going to keep checking every node if that is present in the set or not. So head 2 equals to head 2 dot next, right? If set dot has head 2, return head 2. At the end, null. So this should do the trick, and let's see. Let's run our test cases. To find intersection, this is the first test case. Wow. Okay, it started running. Okay, and it passed. So now let's try to do the same thing using the pointer method. So in this particular case, we have two pointer. First let's create two node variables, right, for head 1 and head 2. So let L1 L2 equals to head 1 and head 2. And now while L1 not equals to L2, at the end it will become we're going to keep running the loop, because at the end anyway, if there is no matching node, they both the linked list will match at the end, at the tail, that is null, right? So we can write it L1 not equal to L2, then we're gonna create L1 equals to L1 equals to, then we have to check if L1 present or not. So L1 if L1, then we have to do L1 dot next, and when L1 become null, or when L1 is not there, and it means our L1 pointer reached to the null, at that time we have to transfer L1 to the head 2. Same way we have to transfer L2 to head 1. L2 dot next, when L2 become null, we have to transfer this to head 1. Simple. The two pointers, the time whatever pointer reached to the null, we are transferring that to the another L1 another linked list. And at the end we just have to return L1. And that's the code, and it should do the trick, and it should return our intersection. Let's try to run the test case. This is the test case for this one, intersection using find intersection pointer. Let's run that, and it passed. So now we know both the solution, or both kind of solution to find the intersection. And one is by saving every node and keep checking it again, and another is by creating two pointer and moving through both the linked lists. So thank you.